bring this. Okay, now I'm recording. Here's problem number 1. If you're watching at home, you can pause your video. Problem number 1. Okay, problem number 2. Is the equation a equals 21,000 parentheses 1 minus 0.12 to the power of t a model of exponential growth or exponential decay? And what is the rate or percent of change per time period? Tyrone, decay. Perla, 12%. You guys are like trying to see who gets it first, right? That's good. I love the competition. Okay. Yes, correct. This is decay. How do I know it's decay? How do I know I'm decaying?
Because it's being subtracted.
The subtraction. Good. Subtraction means decay. And that 0.12 is my percentage, but it's written as a decimal. So I know that 0.12. How do I go from a decimal to a percent?
2 places to the right.
Two decimal places to the right, or what's another way to think about that? You're correct. 2 decimal places to the right, or multiply by what? How do I go from
100?
Yeah, times 100, because you're turning it into a percent times 100. So 0.12, that's my 12%. That's my decay percent rate. So yes, exponential decay, 12%. Not too bad so far, right? If I recall, you guys really like exponential functions for some reason. That was one of like the best topic tests. You guys had a really good score. Questions on this one, number 2. Okay, why am I multiplying by 100? Okay, good question, Janelle. So if I have 0.12, think about it this way. I always like to relate back to money. I always do, because money is like easy for me to understand. How do I say this if I'm talking about money? That's 12 what? Good, Janelle. That's 12 cents, right? 12 cents. Okay, cents are pennies. How many pennies make up a dollar? 100, right? So this is 12 out of 100. 12 100ths. Now, if I want to know how much of a percent that is, a percent is how much you have out of 100. That's what the word percent means. Per means per, and then cent means 100. So how many do I have out of 100? I have 12%. That's why I multiply by 100. Does that make a little more sense? That helps out? Okay, you see. Okay, cool, awesome. So that, but what Perla said at the beginning, when all you have to do is move the decimal place 2 times, same idea. You're doing the same thing. All right, number 3. The amount Mike gets paid weekly can be represented by the expression 2.50A plus 290, where A is the number of cell phone accessories he sells that week. What is the constant term in this expression, and what does it mean? Ooh, so here's a vocabulary word. Constant. What is the constant? If I have an expression, what is a constant? Silence. Okay, so we got to go back to this. So I'm going to rewrite my expression on the side over here. 2.50A plus 290. Jalen says a constant is a constant. Okay, well, which of these numbers is my constant?
I think it might be 250 and 290.
Okay, so it's one of them. Constants are going to be numbers, but there's something specific about a constant.
Wait, isn't like 290 like the base?
Kind of, yeah. So if this was a linear function, what would 290 be?
Like the y-intercept, I guess? where he starts
Exactly.
off, and then every phone accessory he sells, he would go up 250 and so on.
Exactly. So that's on linear functions, and that's totally correct. But when we're just talking about the expression, like just that mathematical phrase that we have written down here, 290 is the constant. That's just what it's called. It's the constant. And 2.50 has a different name, but it also starts with a C. Does anybody know this? I'm sure you guys know this. It starts with a C. When I say it, you guys are going to be like, oh, duh. Emily, say it publicly. You have it correct. Share it with the class.
Miss Lopez, why is it always Emily with these things? Like when you ask us a question what something's called, we never know it, but Emily does.
Emily has a very good memory. This is our coefficient. This is our coefficient. So the difference is coefficients have variables next to them. By the way, the A, that's my variable. And constants are the numbers that are all alone. Okay, so anytime that you have a coefficient, that means that that number has a variable attached to it. So 2.50 is my coefficient, A is my variable, and 290 is my constant. So now that I know 290 is my constant, which answer am I going to select here? Yeah. Yeah, Tyrone, go for it. Yeah, you're correct. C, the amount he is guaranteed to be paid each week, because we know that 250 is how much if he happens to sell some cell phone accessories, great. He's going to make 250 off of each one. But 290 is like his, I think Perla said it before, the base amount. It's the y-intercept, it's the starting amount. So we know he'll get 290, and then on top of that, he'll get paid extra if he sells some accessories. All right, any questions on this one? Okay, awesome. Moving right along. Would anyone like to read this one? I know I've been reading a lot. Tyrone, go ahead. Oh, sorry, Tyrone beat you to it.
Oh man.
Oh, he's being nice. You can go.
Yeah, he's being a gentleman. Thank you, Tyrone. A t-shirt company bought a new packaging and tracking system for $100,000. The formula V equals 100,000 times 1 minus 0.125 to the power of y models the value of the system V in dollars after how do you say that? Depreciating?
Yeah, depreciating.
Depreciating for y years. In this formula, what is the meaning of the term y minus 0.125?
Awesome. Okay, so let's think about it. What does that term mean? Okay, so we already know a few things. What do we already know? Let me rewrite this function. V equals 10,000 times 1 minus 0.125 to the power of y. Let's point out what the different things represent. So go ahead, and I already see a couple things in the chat. I see that we know it's going to be decay. How do I know?
Because of the minus.
Because of the minus. So we know it's decay. Okay, what else do we know? What's that 12.5? 12.5 is my what?
I think it's like the decay rate, like.
Yeah, that's what I'm looking for. It's 12.5, but what is it? Is it 12? Because I'm seeing $12.50 and 12.5%.
No,
So is that a percent or dollars?
percent.
Percent. Good. That's always a percent, regardless of what you're talking about. That's the decay rate. So putting it all together, I think Perla said she thinks it might be answer choice C. Do we agree? The value of the system will decrease by 12.5% each year. I see some agreement from Tyrone. Do I have agreement from anyone else? Yes, Janelle's agrees. All right, and Jalen agrees. Awesome. Good job. C is correct. All right, any questions on this one? You guys are doing really well. Okay, here we go. Next one. Okay, moving on to a different. So we were doing A-SSE 1.1. Now we have A-SSE 1.2. Which equation is equivalent to m squared minus 25? Okay, things are a little bit different. Is this an exponential function anymore, or is this something else?
I think it might be a quadratic function.
Okay, how do we always identify quadratics?
The exponent of
Exponent is 2. Perfect. Quadratic. Now with quadratics, lots of times there's different ways to represent quadratic functions, right? We saw yesterday vertex form, standard form, and factored form. And you can switch back and forth using a little bit of math. So in this case, let's look at our answer choices. What does it look like we might be able to do? What do you guys think?
I was thinking about C and D, but now that I think about it, I don't think it's those anymore. So
Well, what do C and D look like if you were talking about quadratics?
the factor, they factor it. But
Yeah, it kind of looks like factored form, right? Do we agree? Okay. Well, if that's factored form, what can I do to those two factors to get it to maybe turn into this? We already have some guesses going on here, but we can't just guess. We have to check
oh, I
to
think
see.
it is C. Never mind, because if you do m times n is m squared, m times 5m, and then negative m, I mean negative 5 times n is negative 5. So those will cross out, and then you just have the negative 5 and the 5. That's 25.
And
So
what process did you just do? What's that called?
FOIL.
Foil. So Perla just foiled. So let's actually take a look at what she did. So this is m minus 5 times n plus 5. And we're going to FOIL to see what happens. So foiling m times m, what do I get?
M squared.
M squared. M times 5. 5m. Negative 5 times m. Good, negative 5m. Oh, this should have an m, I'm sorry. And then finally, negative 5 times positive 5. Good, negative 25. Okay, so there you go. So there's my foiling. And Perla, what happens?
The 5 and the negative 5 like get eliminated.
Yeah, because what's 5 minus 5?
0.
0. So these cross out. And what am I left with?
M squared minus 25.
Exactly. And that matches what I started out with. So we know it's C. Now, very quickly, I'm going to go to what Jalen thought it might have been, because this one looks very promising, right? It looks like it might work out because you have m and you have a negative 5 and they're being squared, and it's like, okay, that can match, right? Well, let's see why it doesn't match. When I take things to the power of 2, what am I doing to it?
Multiplying it by itself.
By itself, exactly. So this would be m minus 5 times m minus 5. Okay, well now I would have to FOIL just like we did before. So if I FOIL this, I would get m squared minus 5m minus 5m What's negative 5 times negative 5? Yeah, this would be plus 25. And not only that, do these cancel out with each other?
No.
They don't. So this would be m squared minus 10m plus 25, which does not match what I needed. Okay. So that's why, it might have looked correct, but you can't know for sure until you try it out, until you FOIL, until you test it to see if it works. But that was if I were doing this test and I wasn't really sure, I would at least be able to eliminate A and B and then choose between C and D. Questions on this one?
No.
Tyrone is good. Perla's good. Jalen, you good? You understand now? Awesome, awesome. Alrighty. Next up, here's a similar one. I want you guys to try this one now. David correctly factored the expression m squared minus 12m minus 64. Which expression did he write? So remember, factoring is the opposite of foiling. Okay? Foiling. So he went from this to one of those options. You're trying to figure out which option is correct. So there's two ways to do this. You can either factor it yourself and see what you get, or you can look at your options, FOIL them, and see which one leads to the same answer. So go ahead and try it out on your own. If you have an answer, try it first privately in the chat so that you can give everyone else a chance to try it out, and then we'll do it together.
Ms. Lopez, do you think you can help me with the ACD thing?
ACD thing?
No, ACED, the standard. I don't know what they're called. Cause that one's hard. I tried doing it on the homework. I couldn't do. I only did like one. I couldn't do any of
Yeah,
them.
that one's like notoriously difficult because that one is all about writing expressions, right? Is that what that is?
Yes.
CED, did you say CED 1.2?
I think it's 1.2.
Okay.
The very
Well,
first.
if you want to definitely work on those during office hours for sure, especially because we're going to be moving on to functions next, so we're not going to really like look at that anymore. But I'm looking at it now on your homework, and yeah, some are easy, but some are really hard. So
Okay, thank you.
I understand. Okay. And REI too. Yeah, REI, CED and REI are like two of the hardest ones, but also two of the most important ones. So we have to make sure we understand them. Okay. All right, guys. Hopefully you guys had enough time to think about it. I see some answers in the chat, and everybody who sent their private answer has the same answer. So it sounds like C was winning, but let's actually see if that's correct. So two ways, like I said, you can either look at what we've got and factor it. And in order to factor it, remember this, we need two numbers that multiply to make what?
Negative 64.
They have to multiply to make negative 64, and they need to add up to negative 12. Negative 12, and that's important. So what two numbers multiply to make negative 64 and add up to make negative 12?
Negative 16 and 4.
Yeah, negative 16 and positive 4. So this was m minus 16 and m plus 4. So that was definitely correct. And if you would prefer to FOIL instead, if you just think that's a little bit easier, you could have done that as well. So m times m is m squared. M times 4 is 4m minus 16m minus 64. And then 4 minus 16 is negative 12. 2 ways to do it. Both ways get you the correct answer. Do I have any questions on this one? All right, keep it going. All right, now more quadratics. Now notice in the previous one, we were going from standard form to what? This was standard form, and what were my answers? Good, Tyrone. They were all factored. We were going from standard to factored. Now what am I going from? I'm going from, what's this?
Standard to vertex.
Yeah, this is also standard. But all of these are vertex. And there's a couple of things we can do. There's definitely a couple of strategies, and all of them will get you to the same place, but I want to hear what you guys think. What would you do if you were trying to go from standard form to vertex form?
I would either solve or like FOIL, but I feel like that's not the right one.
That could be, so let me ask you this. If you're taking this test, obviously you can do whatever you want, but if you're taking this test and you see all of these answer choices, do you think it makes sense to try to turn all of those into standard form? So do that 4 times, or would it make more sense to turn the standard form one into vertex form?
Yeah, that makes more sense.
Right, it's like less work, right? Rather than taking all 4 answer choices and going one by one and expanding them and making them look like standard form, which you could do. I'm not saying you can't do that. You could do it. It would just take more time. So to me, it makes a little more sense to look at what we have and to turn it into vertex form. However, how do I do that? That's the question. So how do I go from standard form to vertex form?
Oh, I remember negative b over 2a. Oh, no, never mind. Yeah?
Yeah,
Oh.
yeah. Remember the vertex formula? The vertex formula tells you the vertex. So if you know the vertex, you can match it to the correct answer. So let's use the vertex formula. Perla's got it. Negative b over 2a. All right, so let's plug that in. Negative b over 2a. What's my b?
6.
6. A is 3 and b is 6. So negative b over 2a, that would be negative 6 over 2 times 3, which equals?
Negative 1.
Negative 1. So I know that the x, so my vertex eventually is going to be negative 1 comma something. So which answer choices can I eliminate?
A and B.
I can eliminate A and I can eliminate B. That's good. Okay, well now I know the x, but I don't know the y, so what should I do? Plug. Yes, Tyrone. Don't doubt yourself. You're always doubting yourself, Tyrone. Good job. We're going to plug it in. So 3 times negative 1 squared plus 6 times negative 1 plus 5. Here we go. Negative 1 to the power of 2 is positive 1. Good. And then 1 times 3, that's 3. 6 times negative 1 is negative 6. And then 5. 3 minus 6. 3 minus 6.
Negative 3.
Negative 3. And then negative 3 plus 5.
Is 2. I was
It's
thinking 1 for some reason.
It's 2. So what's my answer? If my vertex is -1, 2, good. Janelle's got it. Yeah, it's D. Because don't forget, those two values give me the vertex. It's just that you have to make sure you make the x negative. So this is -1, 2. Questions? You guys did it. I barely had to help you. Questions on this one? Something that I want you to always think about when you're working on these problems, guys, is when you see a brand new problem, you click next and a new problem shows up on your screen. There's like 2 questions you should ask yourself. Number 1, what type of function is this question talking about, right? So in this case, we knew it was quadratics. We knew we were talking about quadratics. Because once you know what type of function, you can remember all the different formulas that are part of that function. You can think about all the different forms. So is it standard form? Is it slope intercept form? Is it vertex form? There's a lot of them, right? So all of those things can help you to like contextualize the problem and figure out what it is you need to do. Okay, so that's the first thing that you need to do. And then the second thing is look at the answer choices and think to yourself, which answer choices can I keep and which answer choices can I eliminate? Because if you end up needing to guess, if you are not quite sure and you have to guess, you should always try to eliminate 2 answer choices. So we were able to eliminate A and B, and then from there we were able to get D, but if you had to guess, at least your chances of guessing correctly will be better. Okay? All right. All right, so on that note, let's take a look. This one's a little bit odd. What's weird about this?
Wait, it has both an X and a Y.
Yeah, it's got both X's and Y's, both of them are they've got power of 2. There's kind of like some weird stuff going on in this problem. So I definitely wanted to do this one because this is kind of one of those problems that doesn't fall into the category of linear, quadratic, or exponential. And I'm actually going to go back to this
Miss,
problem.
I think I know what to do. I have an idea, but I'm not sure if it's right.
Okay, well, think about it in 1 second. I just wanted to come back to this problem really quickly because this allows me, I'm going to review something that it's been quite a while. So I just want to review. And I want you guys to write this down in your notebooks. Difference of 2 squares. Okay, write this down because this might come up and we want to make sure that you know it. So anytime that you have 2 numbers, any numbers, so I'm going to call them A and B, that are going to the power of 2, so A squared minus B squared, that's why it's called the difference of 2 squares, right? They're subtracting. When you have the difference of 2 squares, you can factor it, and when you factor it, you will get A plus B. So you'll get A plus B and A minus B. And this is a very special property. It's a very kind of easy thing to remember, but also very important for factoring. So in this example, let's actually see how this worked out for us in this example. Here, I had m squared minus 25. So I had m squared. And then the 25, how do I write that as something to the power of 2? In other words, what to the second power gives me 25?
5.
5. So this is the same as m squared minus 5 squared. And following the rule for the difference of 2 squares, this would be m plus 5 and m minus 5. just following those same rules, okay? A plus B and A minus B. So here, M plus 5 and M minus 5. And notice how that matches perfectly with our answer choice that we ended up choosing, C. So that was a different way to do the same problem. We kind of did it by foiling, but you can also do it by remembering the difference of two squares. Do I have any questions on the difference of two squares? Do you guys still need a second to write it down, or do you have it down? Nobody needs any more time? Okay. So the reason I wanted to bring this up is because, let me actually copy and paste this into what we were working on. Okay, so we were on this problem. Notice that this problem is also a difference of two squares problem. And yes, I am drinking tea. All right, so look at these two values that we're subtracting. The first thing I notice is that they both have the power of 2. So I know that they're both squares, right? However, I also have this like 121 and then the 64. But 121 and 64 are both perfect squares. You can take the square root of those numbers. What's the square root of 121? Good, Tyrone, 11. The square root of 21 is 11. So I can rewrite this like this. I can write 11x to the power of 2. And then what's the square root of 64? Good, 8. So this would be 8y to the power of 2. So following the rule for a difference of two squares, how can I factor this 11x squared minus 8y squared? What would be my two values? And I just realized I color-coded it backwards, but I hope you guys still understand what it means. What would I get? Perla stepped out for a second, so someone else has to speak up. Follow the pattern. This has to become a plus b and a minus b. So in this example, what would be my a? What would be my b?
Your A is 11 and your B is 8. No, never mind. Your A is 121 and then your B. Never mind, I'm confusing myself.
Okay, let me do this again. And I'm going to actually rewrite this with the correct colors so that we can match it a little bit better. Okay. The difference of two squares has to be something to the power of 2 minus something else to the power of 2. Okay? So in this case, like we already said, 121, the square root of 121 is 11, right? So this whole thing, I can rewrite it as 11x to the power of 2. The 64, the square root of 64 is 8. So I can write this as 8y to the power of 2. The difference of two squares is when you have something to the power of 2 minus something else to the power of 2. So in this case, what is my A and what is my B?
Our A is 11 and our B is 8.
But not just 11 and not just 8. I put parentheses there for a reason.
11x squared and 8y squared.
Okay,
Wait,
so my A would be
I have a question.
hold on, let me finish this out. So yes, my A would be 11x and my B would be 8y, those two things together. So then when I factor it, what can I write? It has to be A plus B and A minus B. Just 11 and just 8? No, 11x, yeah. So it'd be 11x plus 8y and 11x minus 8y, which is answer choice C. No, D, sorry. Okay, now you can ask a question, Perla.
No, I got it. Thank you.
Okay. Do I have other questions on this one? This one's tricky. I completely agree. This is tricky. I'm drinking black tea with honey. It's yummy. All right, let's do another. We're moving on to, I have a couple of F, even though technically we don't start functions until tomorrow, these have to do with exponential functions, so I figured they would fit into today's class pretty well. All right, the function f of x equals 250 times 1.12 to the power of x models the number of students at a school x years after it opened. By what rate is the model of students increasing each year? Perla says 12% or 0.12%?
No, 12%. 0.12% is like really, really small.
Right, so good. So even though this is a 0.12 rate, remember that 0.12 is not a percent. It's a decimal. So to turn it into a percent, you have to multiply it by 100 or move the decimal point over 2 spots. So 0.12 is not the percentage, 0.12 is the decimal. The percentage is 12%. That's just something you got to keep track of. So any questions on that? Okay, cool. Similar question. The function f of t equals 24,500 times 0.84 to the power of t models the population of a town t years after 2008. What is the rate? What rate is the population of the town decreasing each year? 16%. Easy peasy. Okay, and why is it 16, Perla? How do you know?
Because it says decreasing, first of all, so we know you're gonna do like subtraction.
Mm-hmm.
We can do it the other way around. If we do 1 minus 0.84, you'll get 16.
So 1 minus 0.84 is 0.16. So here, this would be 1 minus 0.16 to the power of t. So in other words, they already subtracted for you, but before they subtracted, like in the previous step, this would have been written like this, 1 minus 0.16. It's just that they did the math in the actual problem. So the actual rate would be 16%. Don't fall for this trap. What answer choice will you fall for if you're not careful?
B.
Yeah, I bet most of you guys would have chosen B by accident. Don't fall for that trap. That is not the rate. The rate is how much you took away from 1 to get 84. Okay? The rate is how much was taken away, which was 16. Questions on this one? Okay. Just a couple more. We're going to finish early today, which is great because I want you guys to have a little bit of time to work on your homework at the end and to ask any questions you have. The size of a population of gorillas can be modeled by the function p equals 18 times 1.2 to the power of t, where t is the number of years since 2005. What does the 18 represent in this function? Tyrone, I'll let you read the next one. I'm sorry. So what does that 18 represent? Good terminology, that is the coefficient. However, more specifically, like what does it actually represent? So Perla says B, but then she was like, oops, no. Okay. She's second guessing herself.
No, I read it wrong. It
read
wasn't
it
like
wrong.
a definite answer. It was just like, oh, it's B.
What does everyone else think? Okay, Perla says B again.
Yes, can I explain why?
Hold up, not yet, because Tyrone says C. Jalen agrees with Perla. Confusion, confusion. Let's go back to this. What does A represent again? What does B represent? Always.
The base rate. Oh, wait.
What's A?
For the, I'll think about. Never mind. I just come.
A is the base. A is the starting amount. And B is the growth. Good. So if we're following that rule, 18 is the starting amount and 1.25 is the growth. So which answer is correct?
B.
B is correct, yes.
Hey, I should take my own advice.
B is correct, yes. So 18 is the amount of gorillas at the start, so at 2005. After that, it went up. How do I know that it went up and not down, by the way?
Because it's above 1, it's not less than 1. So we know they added it.
Good. 1.2 is greater than 1, so it's adding. Cool. Tyrone, go ahead.
The Boonville History Museum had 2,500. It's echoing.
It's okay. Talk fast and we'll hear it.
The Boonville History Museum had 2,500 visitors in 1980. The number of visitors has decreased by 2.5%.
Oh no. How come it worked when Perla was reading? That's weird. Okay, we're waiting.
The Boonville History Museum had 25,000 visitors in 1980. The number of visitors has decreased by 2.5% each year since 1980. Write a function v of t to represent the number of visitors to the Boonville History Museum t years after 1980.
Awesome. Who would like to start us off? Emily has been voluntold. Anyone can do it though. So this is, first of all, exponential, linear, or quadratic? And how do you know? Exponential, how do we know? There's something a little bit more important than just the each. because you can still increase, you can still decrease. Emily had, okay, the percentage gives it away. Percents are always exponential, always, always, always. So I know it's exponential from that percentage. Well, since I know it's going to be exponential, well, I know that this is exponential. Am I growing or decreasing or decaying? It's decay. Exactly. So I know that this is going to be A and then 1 minus the rate to the power of t. So let's fill in the blanks. What is my A? What is my rate? What do I write? 25,000, good. That's my A. And then 1 minus, what's my rate? 2.5%. Be careful. This is 2.5%. 2.5, now we got to go backwards. 2.5% as a decimal would be, no one has it yet.
2.5 is a decimal.
Mm-hmm.
0.25, not 1.25, 0.25. Or 0.00000.
There we go.
Yeah, 0.0000000.
How many zeros?
10,000.
How many zeros?
10,000.
Just these, okay? 0.025. Because how many places am I moving that decimal? How many places over? 2. But this time, instead of going to the right, I have to go 2 decimal places to the left, and then I add a 0 in there to fill that spot. So it's 0.025. That's the number that I put in here. You have to be very, very, very careful. That's a very common mistake, and you don't want to make that mistake. Okay, but now let's actually simplify this, because when I write my final function, I want to do that subtraction. So what's 1 minus 0.025? Good, Tyrone. 0.975 to the power of t. There is my answer. Okay, so don't be so quick to jump to conclusions and think that's it. You have to be very careful, because those little tiny mistakes can throw you off completely. Do I have any questions on this one? Okay, I believe we have one more problem left, and then the rest of the time will be spent on the homework assignments. Tyrone, do you want to read this one too? It's the last one. Or somebody else if they would like to. Who wants to read? Going once? Jalen. Oh, Jalen. Go for it, Jalen. Come on. You're good? All right, fine. I'll read it. All right. The starting annual salary for an office worker at a company is $29,000. If the company awards an annual increase of 6.2%, which graph models this situation after the office worker receives X annual increase? Okay, couple things. First thing is I can write the function. So just like this previous example that we just did, let's write this function. What do I write first?
29,000.
Mm-hmm.
Oh, you could hear that, Miss? I couldn't hear myself.
Yeah, I heard you. 29,000 times, is this growth or decay? Growth. So it's going to be 1 plus something. What am I adding? Good, Janelli. 0.062 to the power of t. Now, when I actually simplify that and add, my final answer would be y equals 29,000 times 1.062 to the power of t. So I know that I know a couple of things. 29,000 is the what?
Base, where we start off at.
Where we start off at. So can I eliminate any answer choices? C and D, good. C and D both start at 5,000, which is incorrect. Okay, so now I'm looking at these two, and I know that my growth rate is 1.062. So we can do a couple of things. One thing that I can do is check to see if, because I know that the first point is correct. I know that this is about 29,000, right? For both of them. What I can check to see is if the second point is correct, because what I can do is after 1 year or one increase, I can see what I get. If I started with 29,000 and I'm increasing by 6.2%, I can now multiply. So try on your calculator, what's 29,000 times 1.062? What do we get? Don't forget, it's times 1.062. $30,798. So after 1 year, he should have $30,798. So now we got to check. Look at what you have over here versus over here. Which of those is on approximately 30,798? A or B? A, yeah. This is approximately 30,798, whereas B had it somewhere around what, like 47,000 or so? Okay, so just based off of that, we know it's A. We definitely know it's A. Does anyone have any questions on how I did that? That was a little bit different than what we've been doing. Okay. All right, so it is about 2 o'clock now, guys. So you have about 20 minutes. I want you guys to pull up your individual homework packets. And what I'm going to do is I'm just going to turn off my screen share. And I'm going to stop recording so that